So this problem says to write the expression as an algebraic expression in x for x is greater than 0. And our expression is sine of tan inverse of x. So the way I would start this problem is first I would define my inside function as theta. So let's call theta is equal to tan inverse of x. And then if we take the tan of both sides, we can cancel out the tan inverse to make the problem tan theta is equal to x. From here, let's draw a right triangle. Pretend it's a right triangle. If this is our angle theta, tan of theta is the ratio of the opposite over the adjacent. So since tan is the ratio of opposite over adjacent, we can write this x as a fraction by writing it as x over 1. So let's call the opposite side would be the numerator, the top of the fraction, which is x, and the adjacent side is our 1. So the adjacent side is the one that touches theta that's not the hypotenuse. Okay, so from here this gives us our at least two sides of our right triangle. Let's plug in, if this is sine of theta, since we defined the inside function was theta, we know that sine of theta is equal to the opposite over the hypotenuse. So we have, our function already has the opposite, which is x. We need to find what the hypotenuse is. In order to find the hypotenuse, since we have two sides of a right triangle, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, where c is the hypotenuse. So let's plug in 1 squared plus x squared is equal to c squared. So 1 squared is just 1, and to solve for c, let's take the square root. So we get the square root of 1 plus x squared. So that is this side. And we know that the hypotenuse can never be negative, so it could have been plus or minus when we took the square root of both sides, but we're choosing the positive since the hypotenuse is always positive. And so that gives us an expression for x for the hypotenuse. We could plug that in to the denominator is 1 plus x squared. So that would be what sine of theta is equal to. I'm assuming that we don't have to rationalize the denominator because that might be a little tricky. But if you do need to rationalize the denominator, leave me a comment and I can do that in another video for you. So I hope this was helpful. If it was, please subscribe to my channel and click the notification bell so that you'll be notified whenever I make a new video. Thanks.